Okay, today we're going to do lesson 5 for module 3, which is a continuation of finding common denominators using the rectangular fraction model, but this time we are going to be subtracting these fractions. So let's practice. So question number 2 in our homework sets says find the difference, and the difference I know is the answer to a subtraction problem. So use a rectangular fraction model to find the common denominators. Simplify your answer if possible. So I know I need to use a rectangular fraction model because it's asking me to find my common denominators, and then I'm going to subtract. So let's look at A. 5/6 minus 1/3. So just like when we add, we're going to start by just representing them with a model. So I'm going to do 5/6 by first breaking it up into sixths because the denominator is 6. So 1, 2, 3, 4, 5. And I'm going to try to lightly shade this in. When you're doing it on your paper, it'll be easier to shade with your pencil. So this represents 5/6. And then I'm subtracting 1/3. And just like when you add, you do your second number horizontally, just so you can see how they overlap one another. And then this is my 1/3 because it's 1 out of 3 pieces that are shaded in. So I have 5/6 minus 1/3. And you can see here by looking at these models that these pieces are different sized. My 1/3 is much bigger than my 1/6. And because they're different sizes, I can't really take away 1/3 from 5/6 and know what that actually means. So I need to find that common denominator, which means that my denominator of these need to be the same number. And the way I can do that is by overlapping them. So I can take this 5/6 and divide it into thirds. And I can take this 1/3 and divide it into sixths. 1, 2, 3, 1, 2, 3, 4, 5, 6. So what I just did is I changed the notation of my fraction. My value is still the same, but how I can write it is differently. And now they'll have a common denominator because now instead of being out of 6, this is out of 18. Because I took my sixths and I times it by 3. And now shaded in, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Because I took my 5 and I times it by 3, right? I'm timesing it by the opposite denominator here. So now I have 5/18, and my 1/3 is now also out of 15 because I have 15 pieces. And my 1 became 1, 2, 3, 4, 5, 6. So it became 6/15 because I really times them both by 5 and 5. So my new equation here is 15/18 minus 6/15. Wait a minute. 1, 2, 3, 4, 5, 6. This isn't 15, this is 18. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That would have been a problem. Now I have the same denominator in both. So times by 6. I'm making some silly math mistakes here. So now that I have the same denominator in both, my 5/6 and my 1/3, I've rewritten as 15/18 minus 6/18. So my 18 stays the same because when I subtract fractions, my denominator stays the same. But now my 15/6, I can do 15 minus 6. And really, when I take 6 away, 1, 2, 3, 4, 5, 6, I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9. So my final answer is 9/18 because I took my 15/18 and I took away 6 of them. Now 9/18 can be simplified, and they're asking me to simplify my answer. And I know it can be simplified because 9 can go into 18. When I look at their common factors, 9's factors include 3, 9, and 1. 18's factors include 2, 9, 3, 6, and 18. And looking at that, I can divide each of them by 9 because 9 goes into both of them. 9 divided by 9 is 1. 18 divided by 9 is 2. So 9/18 can be rewritten as 1/2. So really, 1/2 is my final simplified answer. Let's try it again. This time I have 5/7 minus 2/3. So we're going to start by drawing our models. And again, drawing your models in your book with me, please. 5/7. 1, 2, 3, 4, 5, 6. And I'm going to lightly shade in 5 of them. So there's my 5/7. And 2/3. Lightly shade in 2 of my 3. So now I have my basic model done, and I need to get a common denominator. So I'm going to take my 5/7 and I'm going to split it into thirds. And I'm going to, now my 5/7 has become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of 16, 17, 18, 19, 20, 21. Because I did realistically just times these each by 3. And my 2/3, I'm going to split now into 7ths. 1, 2, 3, 4, 5, 6. So I'm timesing them by 7, which means I should get 14 21s, but let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 15, 16, 17, 18, 19, 20, 21. Perfect. So now I have 15 21s minus 14 21s. And pictorially, all I would do is cross out 14 of these 15. So I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'm left with 1 piece. Numerically, I can do 15 minus 14 is 1, and 21 remains the same. So my final answer becomes 1/21, or 1/21. I can't do any simplifying because 1 is my numerator and 1 is already as small as it can get. Okay, what's word problem it? Katerina needs 3/5 of a kilogram of flour for a recipe. Her mother has 3/7 of a kilogram of flour in her pantry. Is this enough flour for the recipe? If not, how much more will she need? So we know that Katerina needs 3/5 and her mom has 3/7. And so they're asking us, is this enough flour? So is 3/5, is 3/7 like equal to 3/5? And right now, I can't really tell because 3/5 is going to be somehow related to 3/7. I don't know if it's greater or less than or equal to. I'm not sure because right now my denominators are different and I cannot compare fractions until they are the same denominator. So I need to make these fractions the same denominator, and I'm going to do that using my rectangle fraction model skills to give some common denominators. So let's do 3/5. 1, 2, 3, 4, 5. Oops. Just 3 of them. And then 3/7. 1, 2, 3, 4, 5, 6. So interestingly enough, my numerator in both of these is 3, right? So I have a 3 and I have a 3. And that means I'm getting 3 pieces for each one, but my pieces are different sizes, right? So my 5ths are bigger than 7ths. So I think that 3/5 is going to be bigger than 3/7 because a 1/5 of a pie is bigger than a 1/7 of a pie. Because if you're sharing pie with 5 people, you're going to get a bigger slice than if you're sharing the same pie with 7 people. So the smaller the denominator you have, if your numerators are the same, the smaller denominator you have means it's going to be bigger. But let's prove that theory with our models here. So the 3/5 I'm going to break into sevenths. 1, 2, 3, 4, 5, 6. And that has become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Because I times it by 7. Out of 22, 23, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Because 5 times 7 is 35. So 3/5 equals 21/35. And 3/7 equals 15/35. So if I'm now comparing 21/35 is somehow related to 15/35, I can tell that 21/35 is bigger because the denominators are the same. I'm just looking at the numerators, and 21 is bigger than 15. So I was right with my prediction. 21/35 is bigger. So that's a problem for Katerina, because that means that she does not have enough flour because she needs 3/5 and her mom only has 3/7. So no, that is not enough flour for the recipe. So she needs to buy more flour. So if she needs 3/5, if she needs 21/25, so I need a little space here. I love to draw tape diagrams when we're doing word problems like this. So Katerina needs 21/35. I'm using the equivalent fraction with the common denominators for this, so it helps me visualize this. So she needs 21/35 kilograms, and she has 15/35 because she borrowed it from her mom. She has 15/35. We need to know what this number is. How much more does she need to get to 21/35? And this tape diagram, because I know the total and I know one of the pieces and I'm trying to figure out an extra piece, I know that this is asking me to do subtraction. It's kind of like if the tape diagram was 5 and 3 and I'm trying to figure out this missing number. I know that 3 plus this missing number is 5. So that means 5 minus 3 will give me this missing number, which is 2. So the same strategy can be used here. I can take my total, 21/35. I can minus my piece, and I can figure out what this missing number is. So 21/35 minus 15/35. Here's my 21/35. I can just cross them off. I can cross off 15 of them. Or I can just do 21 minus 15 is going to be 6. 35 is the denominator, so it's going to stay 35. So I get 6/35. 6/35. And I don't know if I can simplify this or not. I need to double check it. Factors of 6 are 2, 3, 6, and 1. Factors of 35 are 1, 35, 5, and 7. So I don't see any common factors. So that means I'm going to end with 6/35 kilograms of flour is what she needs. I would write this out much nicer if I had space. But so she needs 6/35 kilograms of flour for her recipe. So main ideas here is that when you're subtracting fractions, you need to find a common denominator, and you can do so pictorially. And then once you find your common denominators using your rectangle fraction models, then you can do your subtraction and find your final answer. So hopefully you have some understanding of how to subtract with fractions when we're finding common denominators today.